Good. I think we are small here, like 4 person. I will start like an introduction session. I would like to introduce myself, and then maybe Alan, you can unmute yourself and you can introduce yourself as well. I know Borlan and Nicolida can't speak because they have technical problem or they at work, but they can write like from where and what they are doing. My name is Tamer Abu Alam. I will be with you during today session, tomorrow session, and the conclusion session of this workshop. I am a coordinator of a project called Cloud Earth Eye. This is a website that all of you register for this workshop. The Cloud Earth Eye is a project funded by the EU in order to run activities like the one that we have today for different level. So we have in our workshop today, we have people who are academic, people who are non-academic but working at university. We have students, and we have also people who are coming from the industry sector. And I can see Sandra is joining us as well. Thanks, Sandra. So Sandra, actually, we are recording this session because of the people who are not able to attend. And I was just introduce myself. My name is Tamer, and I am a coordinator of a project called Cloud Earth Eye. And Cloud Earth Eye is a big umbrella. We have a lot of activities underneath this umbrella. We have education activity, like what we are in now, like a sort of teaching activity or seminars or workshops, short workshops. We have acceleration program, so students or academic who has idea to develop business ideas, they can go to this program. It's called Earth Center Business Design. Actually, this Earth Center Business Design is developed and hosted by Edinburgh University. So Edinburgh is hosting this activity. If you know someone who has already a company, well-established company, and this company is working in things related to environmental issue or big data or biodiversity, we have acceleration program for this company. And very soon next year, we will have like incubation program as well in or underneath the Cloud Earth Eye. Also, we have a conference, and this is great. I can see Borlan from Alicante University. The conference will be at Alicante University this year, and hopefully next year 24, I hope that this conference will go to Edinburgh University. So it will be hosted by Edinburgh University. So this is like a very short introduction about me, and then maybe I can get like short introduction from Alan and Sandra. If you can unmute yourself and just introduce yourself very fast. We can't hear you, Alan. We still can't hear you. Sorry. I think you are unmuted, so we should hear you, but there is something we can't hear you. Yes, try again. Yes, I think I can hear the keyboard. So if you speak, I think we can hear you.
Oh, is it working now?
Yes, yes.
Oh, fantastic.
Yes.
Yeah, my name's Alan. I work at the University of Edinburgh. I'm a sustainability training manager, and I'm part of a department of about 25 people who are trying to negotiate the way of the University of Edinburgh becoming zero carbon by 2040.
Mm-hmm.
Part of my role is to offer training materials. So we have an introductory training offering for all staff and students. carbon literacy, and we're looking at biodiversity, but a handful of other areas that we don't do anything in, and we want to look into planetary boundaries. So that's one of the reasons why I'm here today.
Yep, super. Actually, last week we was at Edinburgh. Our consortium, the Cloud Earth Eye consortium, was at Edinburgh, and I think we meet people from your department. I think his name is Michael, if I remember correctly. Yeah. But actually, I quite impressed by what you are doing at Edinburgh University. You are doing a lot. You are number 4 at worldwide to move sustainability, and number 1 at UK. So really, you are doing great job. Yep. So maybe I can go to Sandra, because I know Sandra maybe can unmute herself and introduce a bit.
Hi, hello, good morning.
Good morning, Sandra. Yes.
Yeah. I just finished my PhD in paleoclimate, paleoenvironment, but I'm like teaching a course in the University of Manchester that's called Creating a Sustainable World, where we like kind of cross all the sustainable development goals, and I'm interested in sustainability. I have worked in labs, and I'm aware of like the LEAF project, and it's something that I'm keen on knowing a bit more, and what is available and what's going on. Mostly is about that.
Super. Yes, great.
Yeah.
So this is good. I think we can like two professional. I don't know is Boral and Nicolida would like to say something. I know that they have a problem with their mics. But at least we have two professional here who are working with sustainability things. So actually, I would love to present what we have here today, my presentation, not in terms of one-way lecture, like in terms of discussion. So the structure of the course, actually, the presentation today is sort of 60 slides. So it's like more than 3 hours presentation. So today we will have like half of it or a bit more than a half. Tomorrow we will have the rest of the presentation, and then we will have like a workshop. This workshop, it will be like open discussion between us, what we are thinking, how we can see the role of the business. And I do hope that Alan can share with us like the success story behind Edinburgh University, how they succeeded to shift the mind of the people, worker and students at Edinburgh, to move towards this, to be number 4 worldwide. And this will be our workshop, which will be sort of second day and the third day. The third day, according to the plan, actually is planned to be 7 of December. But I do hope if you can agree with me to shift it to the 9th of December. I hope that your timetable will be available for this shift. But we can discuss this later at a later stage of this today. Well, so what I will do, I would like to share with you my screen just to see the website of the project and what we are doing in general, because I think you can contribute to this project. And then I will share with you the presentation and start to discuss it. Yep. I hope that you are seeing my screen. This is the website of the Cloud Earth Eye. I think all of you are aware of that because you already presented this or you register for this course from here. Actually, we have different activities. We have like 4 projects funded from different funding agents. We have Cloud Earth Eye, which is umbrella to this project. This is funded from the European Institute of Innovation and Technology. And we have a project called Inspire the Mind. This is funded by Erasmus+. And we have Seed Plus. This is funded from the EU, Horizon Europe. And the Seed Plus will run in the coming year. Will start April, and we have several other small application that aiming to strengthen the project. We're not working alone. We have other like sister projects, and this sister project actually funded underneath something called EIT Hey Initiative. And we hope this several projects will work together for a better Europe. So we aim to like create sort of larger collaboration with business sector, with big universities in Europe. We try now negotiate with Bosch and Mercedes in order to raise fund from them in order to help innovation in Europe. We run a conference. This conference, it's a bit slow here. This conference actually will be, this is the website of the conference. The conference will held in Alicante. This is the second conference. Will be in Alicante next year, 23rd and 25th of May. This conference is a unique conference because it's not academic conference. We invite business people, so sort of discussion between business and academia. Hopefully this year we invite some people from the EU Commission, like policymaker. And also we have a special session for students. So students who has no background on how to present their work, their academic work, we like give him or give them like help in order to present or prepare their abstract, in order to how to present this abstract in context on conference. And if these students already have a business idea, green business idea, we will make them available to the investor during the conference. So the conference actually try to link students with investor, academic, with business sector, and looking to the point of view of a policymaker. So now maybe I can share with you my presentation. So just need to, yes. Yep. Now you see my presentation, right? Yes. Yes. Okay. Super. Thanks, Alan. So actually, the presentation is not very advanced, Sandra. So it's at a level of master degree. So hopefully this will be like used by you, or can be recycled by you in order to use it during your teaching activity. As I said, this presentation will be like an introduction for the workshop, which will be started tomorrow. And during this workshop, we will try to discuss things related to planetary boundary and how we can contribute to this planetary boundary. So actually, the presentation or the talk today actually include like two things. Include evidence and background that highlight why we need this planetary boundary. And second, we have an introduction to the 9 planetary boundaries. For each, we will have like 1 or 2 slides. And the whole presentation will be like introduction to the discussion of tomorrow. This is one of the evidence of a change. You see here on the x-axis, this is an age, like by thousand year, and the y-axis we have oxygen 18, and you can see the change in the oxygen 18 over the time. And then at the last period, it's stable. And actually oxygen 18 is reflection of delta T, change in the temperature. And you can see we have some changes. We have some changing over the time on the temperature increase and decrease. But during the last 100 years, more than 100 years, we have like high temperature and it's almost stable at this scale. This is again the same figure. You can see here, this is the change in the temperature, but during the last, since 1950, the temperature start to increase rapidly, very rapidly. And this is a change of the temperature is around 0.5. This is another evidence. This is a map that show the surface temperature. And you can see between, this is the change in anomaly between 1951 and 1980. So you can imagine this is 1980. So like 30 years from now back. You can see how much, I think, all Europe, we have this increase in the temperature. We have in Central Europe, we have North America and Canada, we have in South America, in Africa, in Australia, we have such high range in the temperature, increasing in the temperature. Here as well, another evidence of a change. It's the sea level. So the sea level in 1990 was, if we assume this is our baseline 0, you can see how the change is increased. So with the time, the sea level increase, and of course, changing the sea level, this is affect very negatively on a lot of things. So it's effect on the cities that near to the shore. It's effect on the land use. It's effect on its indication, the sea level indication actually, that the ice shelf that occur in both Antarctica and the Arctic region start to dissolve. This is from where we can, or where we get the water. Here actually we can see the concentration of CO2, the atmospheric of CO2 against human population. And you can see we have increase. This is the atmospheric of CO2. We have high amount of CO2 since 5,000 years ago, like 260 ppm. And then it's almost stable. And then just 100 years ago, the amount of the CO2 start to increase very rapidly with increasing the population. If we zoom a bit on this, in this part of the slide, increasing CO2 actually is not something good, actually, because its effect, or the CO2 dissolve in the water, in the seawater, and it change the pH, as we can see here. The green is pH minus 0.6 or so, and then the red is minus 12.12. And the change in the pH actually affect or highly impact the organism and the fish and the different fauna that is living in the sea. We have, for example, another evidence due to this CO2 change. I can see a message. I can see a message from, I think the previous graph last 1000 K will be a bit confusing because you are showing a glacier again is the interglacier. Is it normal that glacier do have lower temperature? maybe I can return back to this graph. This one. I think this one that you are.
No, it was the first one that you showed. That was like the last 100,000 years that you're comparing glacial. Yes, this one.
This one, yes.
Yeah, because it's quite normal, because you are comparing glacial times are like always colder than interglacial. What I was pointing it was that what was interesting to show, it was all the last 11,000 years, that's the Holocene. We'll compare with previous interglacials to see if there are so many differences, because this one, I don't know what is the case that you want to build, but like glacials, like from 100,000 to around 12,000, that will be colder anyway.
Yes.
The glacial time.
Yeah, I agree with you. This the glacier time, but the point is that not mainly here. The problem is here, like at the last 100 year. So this is just to show that okay, over the 100,000 year ago, we have a change in the CO2, which means that a change in the temperature.
We didn't have so many change in CO2. It just changed, like, because this is not a CO2 graph.
Sorry,
CO2,
it's delta
yeah.
delta 18 oxygen.
018, yes.
Yes, yes.
Yeah.
But the point here is that at the last 100 year, we have sort of stable temperature. And if we focus here, we can see it's not really stable. It's increasing even. So
yeah, I get it, but I think it's kind of confusing because I don't know. It's a choice anyway. But
yeah,
I like what I'll, in this case, what I'll have is like more interglacials because they are warmer periods, and to see all the other interglacials compare, because you are comparing two different things.
yes.
It's
Yes,
a glacial against interglacial.
Yeah, I completely agree. It will be.
Sorry.
Yeah, no, this is okay. This is okay. You
Yeah.
know, it's just an open discussion.
Yeah.
I completely agree. Yes.
If you go to like the previous interglacial, that is marine isotopic stage 5E, I think the temperature, it will be like a bit higher up than the Holocene,
Yes.
and it will not be so stable. And if you
sorry, Sandra, I couldn't hear you. Sandra?
Yeah.
Sorry, I couldn't hear you. Maybe you can repeat this part?
I think that the best like kind of comparisons will be like to have the like, or the previous inter that fluctuations, and compare that with the whole. You'll be comparing the previous anyway, just a suggestion.
Yeah, sorry again.
Yeah.
I lost your sound, but I agree with you. Maybe this is a confusion slide because you know it show like 100,000 year, and it's better to focus on the last part. But again, this is because this is like for a master level, and this is to show them that the temperature or delta T with the time is changed, but we have this constant value at the last 100 year. But I agree with you. Maybe I can change this slide a bit in the coming presentation. Thanks, Sandra. Also, Alan presents that we use the first graph on this page with CO2 concentration. I will try to open this graph. Yes, this is the one. Yes. Actually, this graph will come once more in my presentation, Alan. So this graph mainly is to show like an overview of the last 100,000 years, but after that we will focus on just this part. You see here, this is the temperature, and this is the sea level, and here is the CO2. So I think this is almost similar to the graph that you are presenting, or you send, Alan. Yes. Well, so here in this graph, actually the most important thing is the correlation between the human population and the CO2. So once we start, you see, once we start to increase the human population in the last 100 to 100 year ago, the CO2 start also increase almost with the same increasing rate. If we focus on this part of the graph and the effect of this CO2 in the global effect, it's not only CO2 on the weather, not only to increase the temperature. It has, of course, effect on this the black material on the Arctic and Antarctic and the dissolving of the ice, but also it's increase the pH and it change the pH in the ocean, and this affects the biodiversity of the animals and fish that lives in the ocean. And we can see here, this is another evidence from the effect of CO2, because CO2 is interact with the aragonite, and it changes the concentration of the aragonite in the ocean. And the aragonite actually is important for the coral reef. So it's again indication, or the CO2 affect negatively on the biodiversity, not just because of this increasing of the temperature, but due to change in the pH of the oceans. This is sort of numbers that indicate how much we are fish from the sea from late 50 until 2000, and you can see increase in the amount of the sea that we fishing, amount of the fish that we are fishing from the sea. So this means that the number of the fish start to increase, and we should include this. We should look at this, the number of animals and the living organisms that we live with. So the biodiversity is something important here. This is like a sketch to show that the number of the people. So in the far future, 1,700, so like 300 years ago, we was something like 650 million person. And you can see here two color. You have the light green and the dark green. And the dark green is the ecosystem that is not affected. So, and the dark green is the ecosystem that affected negatively because of us, because of the people. And you can see with the time, the number of the population increase, 1 billion, 1.6, 2.5, and so on. And you can see the amount of the ecosystem that affected negatively, the dark green color, it start to increase with the time. And now actually we are here, we are somewhere here. So the number of population is 8.2, a bit less. And we almost affect half of the ecosystem that existing. And of course, with the time, with increase the number of population, this will be completely damaged. So actually, with the time, we will damage our planet. This is again the number of marine species and freshwater species and terrestrial species. So this slide is something related to biodiversity. And you can see this is from 1970 up to 2000, so 20 years ago. And you can see the number of the species start to decrease rapidly since 1980 or so, 1980, 1985. And this is indication that we have problem here. So far, I try to present that there is problem. This is a global population. We present this before, but in different scale. You can see that the population here is projected until 2050, and we increase with this rate. And again, this increasing affect negatively everything. So it's affect the population of other animals that is living on terrestrial or fishes, or the water that we are using, the resources that we are using, because we are people, we need to use resources, and using resources mean consume things. Here there is a question mark. So what will happen after 2050? Actually, we have different scenarios. One of them is like the population will start to decrease, which I don't think will happen, or increase slightly, or increase rapidly with the same constant rate that we are now increasing on. So I assume, unfortunately, that we will follow this red line. So and this is again just to highlight the problem. So what's mean increase population? Increased population mean we need to consume more resources, more people need to drink, need to food to eat. We need to change to use more land to produce food for this huge number of people. Not only consuming resources, but we produce pollution. We reduce CO2. We produce CO2. We produce a lot of things that affect negatively our environment. So actually, increased population means both consume resources and more pollution. And this is why we need to define a safe operation space for human society. To develop based on this safe operation, we need to understand it. We need to function within this safe operation limit. And this is why we need this planetary boundary. So planetary boundary simply, the planetary boundary, actually, they are 9 planetary boundary. And its approach to define safe operation space for the human society. It's not solution. So actually, the planetary boundary is not solution. It's just sort indication to show to the people, okay, this year, for example, our emission of CO2 was like this amount. Next year will be at this amount. So are we still within the acceptable limit or not? So it's just the indication to show us that if we are working within the limit that is acceptable or not. And you can see here, we have the green or this line. It's a line between the green and the yellow field. And actually, this line defines the planetary boundary. The red line, this means that it's danger. We are in a danger zone. And the green line, it's acceptable. the yellow line, there is sort of uncertainty there. And this paper actually is published in Nature in 2029. So what is the 9 planetary boundary? We have climate change, we have novel entities, stratospheric ozone depletion, we have atmospheric aerosol loading, we have ocean acidification, biochemical flow, fresh water use, land system change, and biosphere integrity. So this is the 9 planetary boundary that these authors suggest, and they said that in order to save our life, in order to save the future, the next generation, we need to be within this green zone for these 9 topics, or these 9 boundaries. So here again, the planetary boundary actually is the intersection between the green and the yellow. So actually the boundary is here. So planetary boundary is a framework, doesn't dedicate how society should develop. It's not a solution itself. These are political decisions. So actually how society should be work, how industry should work. This is sort of political decisions that is made by politicians based on their measure, but they should consider this planetary boundary into their consideration. So it's like a measure for the politicians, a measure for society to show to the people, okay, this is our situation today, and we would like to go to more or less. So for example, if we say for the climate change, we are somewhere here because we are somewhere here in this yellow field. So it's up to the politician. Would you like to increase climate change and go to the red zone? It can be, or they should reduce the pollution in order to change the climate change from the positive to the negative side, to reducing it and bring it back to the green zone. So again, planetary boundary is just a measure that can be used by society, by politicians, by scientists to measure how much we use our resources, how much we use our environment. So the concept of planetary boundary, it's a 9 global process. It regulates the stability of the land, atmosphere, and the sea. The tipping point in any may be reached, and this is important, the tipping point, when a change in a process doesn't give a linear response. So tipping point, as I will show in the coming slide, actually, is if you come to a point that you can't return back in some of them. So at the climate change, we assume that we can still control it. And you can see several agenda. We have this 2030 agenda, we have 2050 agenda, the net zero agenda. And we aim by 2050 that we should stop the climate change by not producing CO2, which I think it's a bit difficult, but it's something on the agenda of the politician. So if we assume that we pass this this tipping point, it will be a real catastrophe. So there is some process. If we go past the tipping point, it will be so difficult to return it back. So it will be like ongoing process. Estimate for the upper and lower value of the process have been made, between which the response to change is gradual. Exceed these limits is likely to produce sudden catastrophic change to the environment. So this is the definition of this boundary itself. So actually, for each boundary of the 9, the scientist is working in order to define the limits, in order to define this boundary, and exceeding this limit, exceeding this number, can produce sudden and catastrophic change. So we would try, or we hope politician and business sector and society understand that we should be in the green zone. So this is showing the tipping point. In some of these boundary, we almost at the tipping point. And here you can see the tipping point. If we reach the tipping point here and our Earth start to roll down in the other way, we can't return it back. Of course, during the presentation now, you will see that there is something that we can return it back, but actually the majority of these climate change, biodiversity, for example, this is a major problem, because if we lose a species, if we lose a type of animal, we can't get it back. We lost it, no way. So actually, this is the idea of tipping point. Tipping point, just to highlight, okay, if you are before the tipping point, you can still do something. If you at the tipping point, this means too late. So we need to take action before the tipping point. This is how the planetary boundary actually was calculated. As you see, it's different from boundary to another boundary, and this is an example using CO2. And CO2 here was used to define this climate change one. And they start to say, okay, the planetary boundary is between, or they start to calculate it, it's between 350 ppm of CO2 and 550 ppm. So this is our boundary. And this is sort of zone of uncertainty. So they use the lower limit. You can see here, they didn't use the upper limit. They didn't say that our boundary, the CO2 boundary, is 550 ppm, or they didn't go the average. The average is 450, but they actually use the 350. So they use the lower limit of this uncertainty zone to be the planetary boundary. So if we are operated below this number, in case of the CO2, if we are operated below 350, we are in the safe operation zone. But if we just above, we are in an uncertain zone, and we should stop what we are doing. So this is how we define the boundary. So the boundary, we have sort of measurement for each of these 9 boundaries, and we have sort of upper limit, lower limit for the uncertainty, and then we use the lower limit of this uncertainty zone to be the planetary boundary. Any questions so far, or? Okay. Okay, thanks, Alan. This planetary boundary actually define 2 sort of different type. Hi, Katrina. Yes, it's scary. Yes, I agree with you. 2 different type. We have sort of core boundaries, and this is climate change and biodiversity. And maybe I can ask you if you can write in chat, or you can unmute yourself. Which of these 9 boundaries you think that it's the most important things? And this is actually a tricky question. So I do hope that if you can answer by unmute yourself and ask or answer this question, or just write in the chat from your point of view, like Alan or Sandra or Katrina, from your point of view, which of these 9 boundaries you think it's the most important? If there is any answers. Climate change. Okay, Alan say climate change. Katrina said combined. Okay. Any other? Okay, good answer, Bravo. Yeah. So Sandra said, I think we can't separate them. Mainly because if we thought that it would have such a huge impact on the other, maybe I can read. Alan tried to convince us why climate change is most important, because he says that if we try to fix this problem related to climate change, this will have a huge impact on all of other positive impact, of course. Okay, so actually I disagree with Alan. Yes, so now Alan start to change his mind. So actually I start to agree with you, Alan. So actually I agree with Sandra and Katrina that we can't say, even I have my opinion for that. We can't say, for example, climate change is the most important, or atmospheric aerosol is the most important, or oceanic acidification, simply because, as we will see in the coming slides, everything is interconnected. So we can't solve climate change with the land system change, because actually climate change is, or the land system change, contribute to the climate change. So we can't say climate change is the most important because maybe this is contribute to that. Or fresh water, because fresh water, it's catastrophe, as I will present now. This is one of the most important things that you will see, because climate change, we can accept it. We can accept there is a change in the climate. We cannot change that. Accept there is floods in Pakistan, or there is water rivers here in Europe that without water anymore. But fresh water can cause catastrophe because it's linked to political agenda, and you can see there is fight, or there is sort of conflicts, political conflicts can rise from the fresh water. But from my point of view, actually, the most important one is the biodiversity. Even I disagree with myself about this, like, because everything is interconnected. But biodiversity, because, climate change, the temperature changed, okay, but we can work on that. We can reduce the CO2 next year. So if we assume this year we produce 500 million ton, for example, of CO2, okay, maybe we can reduce it to the half next year, and this can have some sort of effect on the climate change. But if there is a species and we lose this species, we lose this animal, we lose this type of fish, there is no way, we just lose it. So actually, my point of view that is biodiversity is one of the most important things. As Katrina said, if we lost dinosaur, we are still fine. Yeah, maybe because we don't eat dinosaurs, but we have this cycle. Yes, okay, Sandra. Yes, so actually we have it's sort of like a tree or boxes. We depend on each other. So of course dinosaurs is already disappeared, but if you look, if you lose a species that we rely on it by indirect ways, this will affect our food system. So actually biodiversity, I think, still the most important one, unless or even I agree completely with you that again it's interconnected. So everything is interconnected. So for these things, that actually the scientific community agrees that we have two core planetary boundary. Climate change, as suggested by Alan, that it's the most important or one of the most important things, and the biodiversity. So this is the core things. And the other is sort of important, but it's not core. Here this table actually is important simply because it's showed to us the things that is already crossed, things that we can avoid, things that we didn't quantify or we couldn't quantify yet, and planetary boundaries that we succeeded to avoid. So, for example, I will start with the things that we avoid. So actually, the ozone layer, the stratospheric ozone, in 90, 80, 85 or something like this, it was sort of catastrophe, and it started to increase the temperature of the Earth due to this depletion on the ozone. And then, as I will present in the coming slides, that the different nations came together to the table, and they succeeded to sign an agreement to reduce the emission of fluorine and chlorine substance, in order to reduce or to cover this ozone layer. And we succeeded. Actually, I didn't remember the date. It will come in one of the next slides. We succeeded in late 80s, early 90s, that to avoid it. So actually, this is a good example. The stratospheric ozone is a good example that even if we pass the tipping point, we can do something. So this is sort of positive impression that we still can do something, and we succeeded to recover the ozone. So as we succeeded to recover it, we can recover other things. There is two things that are not quantified yet: the Earth soils and introduction of novel entities. I know that I think if Katrina remembered during one of the presentation, because Katrina actually is one in Cloud Earth Eye partner. And if you remember, Katrina, during our visit last week at Edinburgh, one of the people there said that Edinburgh University is actually working on this novel identities. So they are working now. So there is an ongoing research in order to define boundaries for these novel identities. So actually, these two planetary boundary, we know it's important, but we can't quantify them yet. For ocean acidification and the freshwater use, you can see we can avoid them. We can solve them. We can help ourselves. You know, planetary boundary, it's sort of not helping the planetary. We don't help the Earth. We help ourselves. We help our future. And of course, we have like climate change. We already crossed the boundary. Biodiversity, we crossed the boundary. Land system change, we cross the boundary. Biogeochemical flow, we cross the boundary. And you can see this is the four major things that we already crossed. Some of them, like biodiversity, we are in the red zone. Some of them, we just cross the boundary and we still in the yellow zone, which is the uncertainty zone. You can see here again the 9 planetary boundary, and it's marked by the risk. So biodiversity, it's high risk. We already, this is a boundary again. You see this yellow line, is this green line, not green, blue line. This blue line actually is a boundary. So in the ocean acidification, we in the safe. In freshwater, we still a bit far away from the boundary. In the ozone, we succeeded. We passed the boundary in 85, 83, something like this. We passed the boundary, but we succeeded to reduce the emission and recover the ozone layer. And now we are again in the safe boundary. But you can see in biodiversity, we already in the high risk, climate change in high risk, biochemical flow again in high risk, and the land system change in the high risk. For the atmospheric results, you see it's not quantified. Novel entity is not quantified. Now we go to the boundaries, boundary by boundary. in order to present them. And please unmute yourself in order to discuss, because now we are going into discussion. And we will start with the core boundaries. And one of the boundaries that we will present is the climate change boundary. And as you see here, we already crossed it. So we already crossed this boundary. We are not in the red zone yet, but we are already in the uncertainty zone. So we are crossing this boundary. And this is some facts about the climate change. So Earth's atmosphere is largely controlled by greenhouse gases in the atmosphere. So if you remember the introduction part, when we start to discuss the CO2 and curve of CO2, because this is the greenhouse gases, and this greenhouse gases, the methane and CO2 and other gases, are control the Earth's temperature, and Earth's temperature, it's controls the climate change by way or another. Evidence shows that period of high atmospheric carbon dioxide are correlated with high average global temperature. So here, why we are using carbon dioxide as sort of indication of this climate change, because there is correlation, and we showed the correlation at the beginning of the talk, that by increasing the carbon dioxide during the last 100 or 200 years, the temperature increased, and as a result, the climate change as well affected. The problem not within the temperature. So if the temperature is increased for 1 or 2 degrees, we as a human, we can accept that. There is no problem. But the problem actually is that the atmospheric temperature affect wind pattern, ocean current, rainfall, and other precipitation. So actually the temperature, when you are speaking with people from sort of middle class educated, not highly educated, and you ask them, okay, what do you think about the atmospheric temperature? And they start to say, okay, atmospheric temperature, during the summer it's too hot, and during the winter it's too cold. But this is not the problem. The problem not is that the summer is hot or winter is cold, actually, because we can see change in the pattern of the wind, change of the wind, change of the ocean current, change in rainfall. If we say, for example, the wind, there is some evidence indicates that the problems that happened this summer in Europe, and as you know that during this summer we found a lot of rivers in Europe without water, simply because there is some changes in the wind pattern over Africa. So actually increase or change in this wind pattern, it's affect where the cloud is going and where we have rainfall, and as a result where we have water. And this is to link the atmospheric temperature with the freshwater use. This is the first link. So actually climate change by indirect way affects the freshwater. Of course, we have positive feedback occurs if we have warmer sea. Of course, if we have warmer sea, this means that the polar ice will melt, and this increase the temperature, the water level, and this again affect the land system change, because once you increase the seawater level, there is cities, a complete cities here, even Indonesia and countries that is almost at the zero level, this island, it will be covered by water. So, and this will cause a problem, because if you can imagine a country like Indonesia, for example, or most of the countries in the East Asia. If you increase the seawater and this country start to have floods and the water and tsunami, and the water start to change the land use, and the water start to cover the lands, where these people will go? it's not only a matter of a changing of the land, but it will create a political problem because these people will move. They start to migrate to other places, to India, to China, maybe to Europe. And it has some consequence for that. Here again, it's thermal expansion and melt of ice, running of land, rise sea level, and without any significant action, we will have like 7 meters by 2100. So you can imagine 7 meters. This means that Southern Europe completely will be covered by water. Full cities will be covered by water. And again, it's not matter of water only, it's matter of everything. You know, you cover land that is used for produce food by water, by seawater. How we can produce food? We can't produce food anymore. Actually, we have a problem in North Africa now due to this climate change, because you know, you increase the sea level, and increasing the sea level include or has sort of effect of the groundwater. So most of the countries in the North Africa, now the groundwater start to be has sort of, it's not groundwater, it's not fresh water anymore. It start to include saline water. So they can't use this water anymore for drink or for using in foods. So you can see just from this page, climate change, only CO2, just CO2, increasing the CO2, change in the climate change. And as a result, we have increase in the sea level. And this increase in the sea level will cause sort of land system change, will cause freshwater change, will cause political conflict. And this is again will return back to your answer that Sandra and Alan and Katrina answered at the beginning of the talk, that we can't say climate change is the most important because, you know, everything is interconnected. Here is the boundary. So as I presented at the beginning of the talk, that we have sort of uncertainty zone, and this uncertainty zone is between 350 ppm and 550 ppm. And the people start to say, okay, we will put the boundary around 400 ppm, and this was in 88. But we succeeded as a human being, of course, we succeeded to make catastrophic things, and we succeeded to cross the boundary. So we crossed the boundary. This was in 88. And now the people start to set another boundary to 350 ppm. So, so actually this is a new boundary, the 350 ppm. And we hope that the UN, with this different sustainability goal, with this their agenda, the European Green Deal agenda, we hope that they or the we can change the mind of the people, how we can reduce or how we can go to below this boundary. And I do hope tomorrow Alan can share with us sort of the success story of Edinburgh University, how you can succeed to change the mind of the academics. Because, you know, I think the problem is our mindset. The problem is with us, not with the, not with industry, for example, because, you know, industry is not working alone. It's not working without human being. We are the people behind the industry. We are the people behind using our cars by unsustainable way. We are behind the change our mobile each year. Why we need to change our mobile each year? Because if you see that your mobile that you are using now and you decide to change it tomorrow, actually this mobile has a footprint, has carbon footprint. It's produced somewhere, maybe in China or maybe somewhere in East Asia, but to produce this mobile, this piece of unit, actually we or this manufacturer start to produce CO2. So we, by indirect way, contribute to this emission. Yeah, so actually, Sandra said that we have higher than 400 ppm since 2016. I completely agree with you, Sandra, because, you know, we're already over the boundary, unfortunately, and we have to do something. And I am afraid to say, you know, all the things that is happened by EU, for example, by the countries that we are coming from. For example, I am sure that you heard about this Green Deal, the European Green Deal. And the European Green Deal tried to put sort of law, put a method, put a sort of a mechanism in order to reduce our CO2 emission. But this will not work simply because our CO2 emission is produced somewhere else. I give you an example now about this, our mobile. You know, when you are saying, okay, Europe didn't produce CO2, this is great, but actually we use product that produced somewhere in China, and the CO2, our carbon footprint, I completely agree, it's not produced here in Europe, it's produced in China. And it will affect, you know, China, the CO2 that is produced in China affect climate change, and it will affect us. So the problem here in planetary boundary is that everything is interconnected. So we try to solve this problem. Now we're still in the climate change. And we actually signed several international agreements. So one of them is Kyoto Protocol, and this is signed in 97 by 84 countries. And this was the first of many major international agreements to address global warming. So this Kyoto Protocol. The Kyoto Protocol set target for reducing the greenhouse gases in the atmosphere. Some major polluter didn't sign the agreement. So major countries that produce CO2 didn't sign this agreement. And then we have the COP21, the famous agreement, the Paris Agreement 2015. And it was signed by 174. And of course, I think all of you remember about Mr. Trump when he was in power, and he decided to remove America from this Paris Agreement. And he say, yeah, we don't want to be in this Paris Agreement anymore. Simply because it's not a matter of just climate change, because, you know, CO2 is the main thing that is coming out of industry sector. And if we would like to reduce CO2, this means that we need to stop some of our industry, and this will affect our economy. So it's not only the 9 planetary boundary that affect each other, but it will affect the economy. If we would like to find a way to reduce the CO2 by putting, for example, the European Green Deal, they start to put some sort of rules. If your company produce this amount of CO2, or if you are getting your product, if you are like getting something in your company from China, and China produce, or this manufacturer that you are using produce this amount of CO2, you should not use their product. Okay, so if I have a company and I use this product from China, for example, and Europe decide, okay, we should not use this product because there is a lot of CO2, what I should do? Should I close my firm? Should I close my industry sector? So actually, it's linked to the industry and the economy, and this one of the things that make it a challenge. Most people accept that the biofuel industry has a role in the reduction of the fossil fuel, and that renewable resources should provide a greater proportion of the energy we use. I don't know, before I go to the next slide, do you agree with this statement? Actually, we need this statement in the coming slides. So most of the people accept that the biofuel industry has a role in the reduction of the fossil, to reduce the fossil fuel. And the renewable resources should provide a greater proportion of the energy that we use. I don't know if you are agree with this statement or disagree, or partially agree. There is any contribution in the chat? No problem, Alan. Actually, I was about, yes, not biofuel. Okay, so Sophie is here. Hi, Sophie. So actually, I am about to suggest to have like 5-minute break, but just we can answer this question, and then we can go to a 5-minute break, and then we start to continue the lecture after 5-minute break. Okay, so some of them, Sophie said partially, the renewable energy, but not biofuel. Okay, Sandra said she is agreed with this statement. Alan would like to have a short break. We will get this short break, a very short, Alan. So actually, simply, I disagree with this statement, simply because, as Sophie said, for example, the biofuel is not good because, you know, in order to produce biofuel, we need to change the land use. We need to change land that produce food in order to produce biofuel. And this will affect the amount of the food that's available for us. Okay, this is the point. But renewable energy, again, is not good thing. Because in order to go for renewable energy, we need to come with a mechanism in order to store the energy, in order to store this electricity. And this is mean that we will use resources of other countries, because, you know, in order to make this battery for our cars, the electricity cars, for example, we need to create battery, and we need to use cobalt and lithium, and the resources that we know for cobalt and lithium actually is produced in poor countries. So in order to go for biofuel or renewable energy, we need to secure resources for that. So it's better than using like classical type of fuel, the fuel that produce CO2, a lot of CO2, but still has negative effect. So Sandra said, I came from down where biofuel is produced from the remain of forest cut, otherwise this forest remain with promote. Well, yes, Sandra, but you know, when you are cut forests, this affects the climate change as well. We need plants in order to reduce the CO2, right? So I think I can stop here. We can keep the discussion open. Just 5-minute break for a cup of tea or coffee, and then we return back to discuss the rest of the different planetary boundary. We're still in the first one.